Welcome back to Train Signal. This is the video for Lab 3, which is Windows 2000 DNS, building a DNS infrastructure for Wired Brain Coffee Incorporated. In this video, we're going to talk about several different concepts, including DNS domains, zones, delegating authority to computers for zones, DNS forwarders, and also caching-only DNS servers. So we're going to cover a lot of different material, and this stuff here is very unique. A lot of times you're not going to find this, at least in this much detail, in books or instructor-led classes. Okay, first thing we're going to do, let's take a look at our scenario here and get a better feel for how Wired Brain Coffee is laid out. Originally, remember, Wired Brain Coffee was only located in this Seattle location here, and they had the one server and approximately 15 different Windows 2000 professional computers. 2 months later, Wired Brain Coffee has expanded like they planned, and they actually opened up a Portland office. What our goal is here is to identify resources in Portland with their own unique name. If you look here, you see this computer name here. Any client computer, for example, we'll just use client 23 as an example, would be client23.portland.wiredbraincoffee.com versus a computer in Seattle, which would be client23.seattle.wiredbraincoffee.com. Okay? What we're doing here essentially is forming different DNS domains. And forming different DNS domains will allow us to put them in Portland or put them in Seattle. And the main benefit to a DNS domain is the organization that it provides. Okay, this is different than a Windows 2000 Active Directory domain. If we have a Windows 2000 Active Directory domain, we won't have to worry about DNS domains because those are created automatically for us. Once again, though, we're still dealing with a standalone environment. So what we're going to take a look at is how we can actually create DNS domains and place our different resources inside different parts of the namespace. Okay, we've talked about this in theory. Let's close this up and go take a look at how we're going to actually do this within our Windows 2000 DNS. First thing we're going to do is a little bit of cleanup, though, from our last lab. So we're going to terminal service over to SRV11. And this has nothing to do with DNS domains. I'm showing it here just to make sure that you follow through and take this step as well. But what we need to do is actually delete our forward lookup zone and our reverse lookup zone that we left over from the last lab. So I'm going to SRV11 here, and I'm going to delete the forward lookup zone wiredbraincoffee.com. Once again, normally you wouldn't do this. You know, we're only doing this, we're going through different lab situations and scenarios, and this is going to benefit us as far as learning this particular piece. Okay, so once you've deleted this, you can close, and now we're going to log off this machine. And then from the Windows 2000 Professional machine, now we're going to terminal service out to SRV1. Okay, and our main focus then is going to be in SRV1 for a little while, and we're going to work within the DNS domains tool here. So I'm going to open up my DNS console, and I'm going to take a look around here for a little bit. Okay, nothing is really too different right now. We've got our forward lookup zone, wiredbraincoffee.com, just the same as before. Same thing with our reverse lookup zone. So what I'm going to do now is spend a little bit of time adding to what I started discussing previously, just concerning DNS domains. I want to make sure that you understand what the difference is between a DNS domain and a Windows 2000 domain. Okay, a Windows 2000 domain, first off, is created when you install Active Directory and you create a domain controller. And that, if you've set it up before, is started by going to Start, Run, and typing in DC promo at the command line. Okay, and that's where you go through the whole Active Directory structure. You're creating the forest, the tree, all that jazz. Okay, Microsoft, or in Windows 2000 or NT 4.0, a domain is used to group users and computers together, so it's easier to manage them and assign permissions to resources. This is totally different. Okay, within DNS, we use DNS domains to control our, what I would call a namespace or a naming scheme. Right now, all the host records we create are underneath wiredbraincoffee.com. Okay, so this record here is srv-2.wiredbraincoffee.com, and this is srv-10.wiredbraincoffee.com. Does that tell you where this resource is actually located? You should answer no. Okay, and what I mean by that, yeah, you can tell me that this resource is located within this wiredbraincoffee.com DNS domain, but I'm talking about physically located. Okay, in a small network, it's not really a big deal. You may only have 20, 30, 100, 500 machines, and you're not so worried about it. In some larger environments, though, they want to be able to identify through DNS host names where exactly a resource is located. And that's what the concept of a DNS domain is. A DNS domain subdivides our main domain here into smaller parts. Okay? In a second here, what we're going to do is subdivide wiredbraincoffee.com into Seattle and into Portland. And what that'll allow us to do is place resources in both Seattle and into Portland. When a resource is placed in Seattle or Portland, that resource will then take on the name srv-2.seattle.wiredbraincoffee.com, which identifies that resource and tells us where it's located. Okay, let's actually do this. Very simple process. So I'm sitting here at wiredbraincoffee.com, and I'm going to go down to, got leftover problems from our last lab. Let's change this real quick. We're going to set this up and actually make this standard primary here. Okay, and same thing in the reverse lookup zone. Okay, we want both of these to be standard primary, because if it's a standard secondary, we can't do anything with it at all. It's read only. And keep in mind what we did, a couple minutes ago. We actually deleted the other zones on SRV11. Okay, so we changed those over, and now if I go here, right click, I have all of my options back again. I can create host records, alias records, MX records, all this stuff. And we will talk about some of these other records if you're not familiar with what they are right now. Okay, here's what I'm looking for though, a new domain. Here is where I can type in either Seattle or Portland. And I'm going to put in Seattle to start. Click OK. And let's take a look at what we have. Nothing too exciting. The only thing we see here is Seattle underneath wiredbraincoffee.com. So I'm going to create one more domain. And this one I'm going to name Portland. Okay, so now I have two different DNS domains. And like I said before, a host that exists inside Portland is going to take on that name, client1, for example, .portland.wiredbraincoffee.com. So let me go ahead and create a record here and show you what I'm talking about. Okay, I'm going to call this computer, just as a test, SRV44. Why not? Okay, 192.168.1.244, just kind of sticking with our naming standard we have before. I'm going to click on Add Host. Okay, and I'm all done. And this is nothing exciting. I mean, this is really the same thing we were showing before. The big difference now, think of this almost like a file and folder structure. SRV44 is inside the Portland folder that's inside the wiredbraincoffee.com folder. So now we have srv-44.portland.wiredbraincoffee.com. If I go to the properties of this record, this is verified up here as well when you look at the parent domain. Same thing would happen with Seattle. So what I would need to do is take all of my records that I have here that are right underneath wiredbraincoffee.com and take each one of these and divide them up and put them either into Seattle or Portland based upon where those actual computers are located. One last note here on the DNS domains. Keep in mind here, this SRV44 does not exist, but if we had this computer out in the network, we would have to change the primary DNS suffix like we've been doing on all the different systems. So for example, if this was SRV44 we are currently on, we would have to go here, once again, to that primary DNS suffix and change this. And it wouldn't just be wiredbraincoffee.com. I'd have to put in portland.wiredbraincoffee.com. Okay, just to make sure that you understand that. So any computer that's inside Portland or Seattle would have to change their primary DNS suffix to reflect this. Okay, we're going to leave domains here and we're going to start talking about DNS zones and what the difference is between zones and domains. First off, don't forget, with domains now, we have these three different pieces. And one thing we didn't mention, one server, SRV1, is responsible for resolving names for all three of these different domains: wiredbraincoffee.com, seattle.wiredbraincoffee.com, and portland.wiredbraincoffee.com. With zones, what we're going to be doing is delegating a piece of the namespace to another server. This is called delegating authority. Let me repeat that. With the zone, we're going to be delegating authority to a piece of the DNS namespace to another DNS server. What that means is this. Right now, like I mentioned, SRV1 is responsible for these three different domains. What I can do, though, instead of having SRV1 being responsible for Seattle and Portland locations, I can have another DNS server set up in Portland and have that particular server authoritative or responsible for all the host name resolution that goes on in Portland. To do this, what I need to do is delegate a piece of this namespace off to that server. In our example here, in a little bit, we're going to set up SRV11 to be the server we're talking about. So what will happen then is SRV1, who is normally responsible for name resolution for all three of these domains, is going to give control of Portland over to SRV11. The result of this is that if anybody is trying to resolve a name, for example, for SRV44, who's a host record that exists in Portland underneath wiredbraincoffee.com, what will happen is this. The computer might be, the DNS client, for example, might be configured to go to SRV1 for name resolution. SRV1 will realize that it's not responsible for Portland anymore, and it will refer that request down to SRV11, who is now responsible for Portland. Okay, so this piece is still part of the DNS namespace. It's just no longer hosted by this particular server. Let's talk about some more of the details that go along with this. When we delegate authority to another server, what we're actually doing is we're splitting up the DNS database. Okay? Before, SRV1 had one database on it that contained host records for all three of these different domains. Now we're going to have two databases, though. One database will be maintained by SRV1, and that's going to be the zone for wiredbraincoffee.com in Seattle, and another database will be maintained on server 11, and that'll be the database for Portland. Okay, let's take a look at how this is actually done. So we're sitting here at SRV1 once again, and what I'm going to do is right-click on wiredbraincoffee.com. And right underneath New Domain, now I see New Delegation. Okay, and this is fairly straightforward. We walk through this, and now we're going to talk about the delegated domain. And you don't have to have a domain created already. For example, we already have Seattle and Portland created here because we're going through an example, but I could have just typed in Portland without, previously creating Portland. Okay, so I'm going to type Portland. Not like that, I'm not. Okay, Portland. Notice our fully qualified domain name below. Click Next. Now it's time to specify the name server who we're delegating this responsibility to. So I click Add, and I've got to go Browse for it. Okay, there's SRV11, so I pick out SRV11, click OK. I've got my server name up here, I've got my IP address down here, that's good. Okay, that looks good. I click Next, and I'm all set. Okay, notice what we have here now. Now we have a gray folder with a piece of paper on here indicating that this has been delegated out, and we still have this Portland domain. This will no longer be here. What we need to do is actually refresh, and now you see the Portland domain has disappeared. It's now turned into what we call a delegated zone. Okay, so this shows up underneath wiredbraincoffee.com, and if I open up Portland, what I see here is what I call a glue record. This computer here, SRV11, is linked up to the top. Okay, and this is the name server that's responsible for portland.wiredbraincoffee.com. Okay, our next job is to actually go over to SRV11 and create our forward and reverse lookup zone. Because right now there's nobody, this name server may be responsible for Portland, but it's not configured to resolve any host names to IP addresses. So we have to go over to SRV11 and address this issue. So what we're going to do is, just going to disconnect from this session and scoot on over to SRV11. Click OK. Let's go open up DNS, see what we see here. Okay. Still have SRV1 up here, that doesn't matter. If you weren't aware of this, I showed you this before. By right-clicking here, connect to computer, I was able to add this computer. Just as easily, I can come up here and delete, and it's not like I'm deleting the whole server, it's just deleting it out of my toolbox, which is called a console here. Okay, so let's take a look what we have. SRV11 has no forward lookup zone and no reverse lookup zone. So how are we going to set this up? Well, first thing we need to do is come in here and create a new zone. So I go to new zone. Next, I'm creating a standard primary zone. Okay, next, name of the zone. This is going to be Portland.wiredbraincoffee.com. Double check this, Portland.wiredbraincoffee.com. Good. Next, notice the name of the file just keeps adding on names depending upon what the zone name is itself. Next, and finished. Okay, fairly straightforward, no big deal there. So by creating that zone, in addition to the name server record, I'm also getting a start of authority record, just like I do anytime I create any new forward lookup zone. Let's do the same thing for the reverse lookup zone. Okay, I'm going to next, standard primary, and I'm going to specify a network ID. Now, because we're in a simulated lab environment, I'm going to be using a network ID of 192.168.1. That happens to be the IP address of this computer, and it also happens to be the network ID that the Seattle network is on. Okay, so in a real-world environment, this wouldn't be the case. If you have two different networks that are connected together, such as our wiredbraincoffee.com Portland office and Seattle office, they would have to exist on different network IDs. Okay, so not entirely realistic as far as what we're setting up and what we've shown, but that's okay. It's not the concept anyway. So let's put that in 192.168.1. Okay, we've got this automatically generated, and finish. So that portion there is fairly straightforward, and what we've done so far, we've done everything that's necessary to delegate authority down to this computer, and SRV11 is now capable of resolving any host names to IP addresses for records that exist within Portland. Okay. Our next challenge, though, we don't have any records even in here, so that would be the next thing that we'd want to work on. Okay, next thing I'm going to do here, we're going to create some hosts on the Portland domain here, just get a feel for how this works and do some testing. So we're going to go to new host. Nothing fancy here. We're going to use client 100. 192. Oops. Okay, add host, and we'll use 101. Couple more here. These are going to be the same ones you're creating within your lab environment as well. And my last one. Okay, let's double check, make sure we have all these. So I've got, I messed them up, but that's okay. Client 1 at 192.168.1.101. Actually better change this, we're going to have discrepancy here. Okay, and this is a good point here. Notice I can't change this. Highlights, try to delete it and it won't change. So what I'm going to have to do here is delete this record and recreate it. Okay, so we'll do a new host, client 101, correct? Yes. 192.168.1.101. Update my PTR. Okay, we'll do for 102. Oops. Gotta be careful. Add host. And in my last one, client 103. Okay, I've got more records than I really wanted, so we'll just get rid of these, make it easy. Okay, 100, 101, 102, 103. I'm going to refresh, see what we get here. Where's my refresh? Okay, we're doing okay there. And in our reverse lookup zone, that looks good as well. 100, 101, 102, 103. So from here, we're going to move forward. And next I'm going to do is play around on our actual client computer, client 100, client 1, excuse me. And I want to take a look and see what this actually does. So let's disconnect. Okay, we're back in client 1 now. And what we want to do first here is take a look at our DNS settings on our network card. So we're going to go to the network card properties and the properties of TCP/IP and take a look at our DNS settings. Previously we had set a preferred DNS server pointing to SRv11. We're going to change that now to SRv1, and we're going to change our alternate DNS setting to a blank setting. We're not going to use an alternate just for our lab tests at this point. So I'm going to click OK here. And the reason we're changing is because SRv11 is no longer responsible for the wiredbraincoffee.com zone. We just delegated authority, so it's now only responsible for the Portland.wiredbraincoffee.com zone. So for our DNS, or our NS lookup test, what we want to do is configure the settings how we just did, and then we're going to run NS lookup. So we're going back to start run in the command prompt, and now I'm going to type in NS lookup here, and we're going to take a look at a couple things. Okay, this is no big deal. This is what we've seen all along. We see our default server setting. SRv1 is now a preferred DNS server, and the IP address of SRv1. Next, we're going to take a look and just test a couple of hostname resolutions. So we'll try out client 1. Okay, no problem. Just to make sure you're comfortable with what you see here. Server and address. This here is showing us the exact same information we see here. The default server, which is our preferred DNS server, and the IP address of our preferred DNS server. What we see here is the actual hostname resolution. Here's the host, client1.wiredbraincoffee.com, and here's the IP address of that host, 192.168.1.1. So this information was pulled straight from a DNS resource record right out of the forward lookup zone for wiredbraincoffee.com. Okay, let's try a couple more. SRv11. Okay, and keep this in mind. Even though SRv11 is now responsible for or authoritative over the Portland.wiredbraincoffee.com zone, the actual host record for this computer still exists in wiredbraincoffee.com, 192.168.1.211. Okay, let's try one more now. And what we're going to look at, keep in mind, like I just said, this computer is authoritative over Portland.wiredbraincoffee.com. So let me enter a host record here and ask your opinion on this real quick. So I'm going to put in here client 100.portland. Let's double check our spelling. Client 100.portland.wiredbraincoffee.com. And before I hit enter, let's talk about what's going to happen here. Now I'm asking my preferred DNS server. I'm always going to ask my preferred DNS server for my host name resolution first. Okay? And as long as SRv1 is there, we're going to go through SRv1, and my client computer, client 1 that we're working on right now, is not going to go through anybody else. The problem is SRv1 is no longer authoritative for this record. Take a look. If you look inside the forward lookup zone on SRv1, you'll see that it hosts the domain wiredbraincoffee.com, but it is no longer authoritative over Portland.wiredbraincoffee.com. Okay, and therefore it's not capable of resolving this host name to an IP address. So when I hit enter, let's take a look at what we see. Now this is no different than what we saw above. Okay, this is telling us our default server, once again, our preferred DNS server is SRv1 at the same IP address. And this looks fairly similar to what we saw as well. client100.portland.wiredbraincoffee.com, this is just the name of the host record and the domain names, and this is the IP address. So we were able to get an answer to our request. But notice what it says here, non-authoritative answer. What this is telling us is that SRv1 is not authoritative over this record, and this information was collected from another DNS server. Okay, and that's indeed what happened here. When SRv1 was queried for this record client 100, it passed a request on to SRv11. SRv11 did have an entry for client 100. We entered that previously. This was then supplied back to SRv1, and SRv1 presented us with the IP address and informed us that they're not authoritative over this answer, meaning they got it from somebody else, another DNS server. Let's take a look at another record we could type in. www.microsoft.com. Okay, and this is very common. We don't normally do it in DNS lookup, but if you were to open Internet Explorer and try to go out to the Microsoft website, the same process is going on. You have to resolve the host name www.microsoft.com to an IP address. Now the problem here, I'm not connected to the internet right now. So if I hit enter, it's gonna give us an error message telling us it couldn't find the host record. Okay, but if you have a computer that's connected to the internet, you can try this out. And if you hit enter, what's going to happen, you'll see this information just like we always do. Down here though, where it tells me the DNS request timed out, you're going to see name, and it's going to list off all the different Microsoft DNS servers. So you may see 4, 5, 6 different, www servers, but you may see 4, 5, 6 different www servers, and you're going to see the IP addresses for each one of those. Okay, and one thing that's important to point out, it will still be non-authoritative. And the way this works, once again, you're asking SRv1 for the information about www.microsoft.com. SRv1's not capable of resolving that. So what SRv1 does is passes it on either to a secondary zone underneath it, okay, another zone that's authoritative, or it's going to pass this request out to the internet through the use of our next concept we're going to talk about, DNS forwarders. DNS forwarding allows us to forward off DNS requests to a server that can resolve a host name to IP address resolution. Let's go ahead and minimize this. We're going to go take a look at SRv11. What we're going to show up is just some basic information first. We want to make sure that you understand how to set up the forwarder. And setting that up itself is pretty simple, so we'll go into some more details after we take a look at this. Here's our DNS console, and just so you're not confused, we are on SRv11 here. So we can see the DNS server for both SRv1 and SRv11, but we're managing SRv11 right now. To get to the actual forwarding tab, you right click on SRv11 or SRv1 if you want to manage that one. Click Properties and then go to the forwarding tab. Okay, when I click Forwarders, you'll notice that forwarders are not enabled currently. To enable forwarders, what I can do is check this box, and now I have to specify an IP address. The IP address you specify is going to be the DNS server that you want to forward DNS requests to. So for example, if I'm in a network, small local area network, and my DNS server is responsible for local host name to IP address resolutions, I need some way to resolve host names to IP addresses on the internet. What I could do is specify the IP address of possibly an ISP's DNS server. And to do that, first off, you need to know the IP address of a DNS server. Okay, so I use Earthlink, and for example, Earthlink's DNS server is 207.69.188.187. Okay, and like I said, this IP address is strictly provided from your ISP, so what you need to do is figure out what the DNS servers are for your ISP. After you have that, you can click Add. If you have additional ones, you can supply as many different ones as you'd like. And then I click OK. And that would be enough to set up forwarding. So let's just click OK. We'll come back into this window in a second here. I want to make sure that you understand what's going on now. So we're sitting at SRv11. And if a request came into SRv11 for, let's say, www.microsoft.com, when I open up SRv11, take a look at the forward lookup zone for SRv11. The only zone we currently host is portland.wiredbraincoffee.com. So what that means, I'm only able to resolve host names to IP addresses for this particular zone. Now that I've configured a forwarder though, if somebody requested www.microsoft.com, SRv11 would realize it's not capable of resolving host names to IP addresses for the zone, and it would forward off these requests to the DNS server from the ISP, that 207.69.188.187 number. Okay, so that's the basic gist of how a forwarder would work. Let's go back in and take a closer look. So I go back to the Forwarders tab. There's one other setting we want to talk about here, and that's this Do Not Use Recursion setting. Okay, by default, we'll come back in and take a look at this here in 1 second. But by default, if I go out and I try to obtain the IP address for www.microsoft.com, and my ISP's DNS server, the one located at this IP address, cannot help me out, this DNS server will actually attempt to go out onto the internet and try to resolve this host name to an IP address. So I'm going to go looking for www.microsoft.com on my own. Okay? And the problem with doing this is when host name resolutions start happening out on the internet from an internal DNS server, we have security issues. One thing we can do to prevent this is to check this box, Do Not Use Recursion. And when you check this box, what you're saying, you're turning this DNS server into what's called a slave DNS server. Now, if I go out to 207.69.188.187 and that DNS server can't help me out, I'm simply going to return a host not found error to the DNS client who is requesting the IP address. Okay, so I'm not going to be able to help it out any further. With this box unchecked, I'm going to wait this period of time. So if it was 5 seconds, I'm going to wait 5 seconds for this DNS server to help me out. If it can't help me out within 5 seconds, I'm going to take matters into my own hands and go out into the internet and try to resolve this host name to an IP address myself. So as I said, it's a good idea to check this box on any internal DNS server where you've enabled forwarding. Okay, so that's how we have that set up. Another tab you should be familiar with is root hints. Okay, in these root hints, you'll notice you've got 13 different names and IP addresses. And this is how the forwarder, we talked about before, if this is unchecked, and we have this set at 5 seconds, I told you that the DNS server would go out into the internet and try to attempt to resolve this name itself. Well, how does it know where to even go? That's what the root hints do. These are supplied in a file called cache.dns. And every time you load DNS, this information is automatically loaded into the cache, your DNS cache actually. So if this DNS server was attempting to, let's say, resolve www.microsoft.com, and this forwarder was not available, this DNS server would take matters into its own hands and go out and try to resolve that name using one of these IP addresses from the root hints. Okay, these root hints, these are the root servers at the top of the DNS hierarchy. Okay, you're probably familiar with the DNS name resolution hierarchy, where we start at the top, and we go down. So for example, www.microsoft.com, that's actually obtained by going first to the root, then going to the .com server, then going to the Microsoft server, and then finally getting the host name www from Microsoft. So let's take a look back on our forwarders tab here once again. Check Do Not Use Recursion, and let's just clarify this one more time. Now that this setting has been enabled, these root hints will no longer make a difference. Okay, so a client's going to attempt to resolve www.microsoft.com. My next step here in the DNS server is to go out to this IP address and have the ISP's DNS server take care of the job for me. If it can't do it, I simply return a host not found record to the client. Okay, the last concept we're going to cover in this video are caching-only DNS servers. Caching-only DNS servers are a very helpful concept within Windows 2000, and they're very simple to configure. After you've installed DNS, you really don't do anything. There will be no forward lookup zone or reverse lookup zone on a caching-only DNS server. So once you've installed the DNS service, you've got a caching-only DNS server. Let's take a look at a couple diagrams back on Client 1 to explore what I'm talking about. Here we see an example of a caching-only DNS server without a cached entry. We're going to go through this step by step to make sure that you understand it. And this is the same diagram that you see in the book if you want to refer to the book at a later time or now. First, let's understand what the issue is here. Now, this portion here is just our normal DNS setup where we have a client computer, a primary DNS server, and a secondary DNS server. The client computer is configured it as SRv1 as its preferred DNS server and SRv11 as its alternate DNS server. Anytime it has a name resolution request, it goes out to SRv1 for name resolution. So if it's trying to go to www.microsoft.com, SRv1 does not contain a host record because it doesn't even have that zone configured on SRv1. So as we learned with forwarders, what ends up happening is this computer would be responsible for forwarding this out to another DNS server that could handle the request. What we spoke of before was this computer actually talking to this ISP DNS server directly, or talking to the root servers that are configured within the root hints. You don't see those in this picture, but keep in mind there are 13 different root servers that start at the very beginning of the DNS hierarchy. What the problem is with this though? Okay, if we have this client computer going to this DNS server, and this DNS server having to go out and talk to the ISP's DNS server, that's fine. This server will eventually get the name resolution request back for www.microsoft.com. What if we had 5 or 10 other DNS servers though, and different client computers connecting to each one of these? So for example, we might have another client computer down here that's talking to SRv11, and there could be another client computer up here talking to another DNS server on our network, if this indeed was a DNS server. What ends up happening is each one of these DNS servers act separately. So even though this computer just resolved the entry for www.microsoft.com, this DNS server has no idea that this DNS server just went there. So what'll end up happening when this client computer down here that's connected to this DNS server asks for www.microsoft.com, SRv11 will have to go back out to the internet and resolve this name all over again. So we're wasting bandwidth, wasting CPU power when we already had this actual cached entry sitting right here on the server. So, and that's a good point to make to you. These DNS servers do not share a cache. Okay, we only have 2 here, but even if we had 5 or 10 different DNS servers, they don't share their cache with each other. So this DNS server is a completely different cache than what we see down here. That's where the concept of a caching-only DNS server comes in. It's a real good idea, even on a smaller network, to set one computer aside as a caching-only DNS server. And that's what we see here on SRv12. Once again, to set up this caching-only DNS server, the first thing you need to do is install DNS. And that's actually the only thing you need to do on this DNS server. So this one here is configured as a caching-only DNS server. These computers here, SRv1 and SRv11, are configured to forward through SRv12. Now when this client computer makes a request out to SRv1, the DNS request then is forwarded on to SRv12, and SRv12 will be forwarding on to either the ISP's DNS server or then out to the root hints that we discussed before. For our example, we're going to focus on SRv12 just speaking with the ISP DNS server and just forwarding on to this computer. What happens now? This computer is going to ask for www.microsoft.com. It'll make that request out to the DNS server, and the DNS server is going to then forward on to SRv12 because SRv1 does not have an entry for www.microsoft.com. SRv12 then will forward on to the ISP's DNS server, who will then go out to the appropriate root hints, and eventually through the DNS hierarchy will get the IP address for www.microsoft.com. That entry is then cached sitting right here on this server. The next time we go out there, and let's bring up our other diagram here and show this. The next time we go here, another computer comes through and they make a request out to www.microsoft.com. No matter whether we're going to this server or this server, the request will be forwarded on to the caching-only DNS server, and this computer now has a cached entry for www.microsoft.com. So there's no need to go back out to the ISP's DNS server to resolve this hostname. Okay, so that's the concept of a caching-only DNS server. Sits right here, in effect, having a common cache for all the DNS servers that forward through it. So when you're configuring this, I just showed you how to set up forwarders in the last session. What you do here on this computer, you set up the caching-only DNS server as the forwarder. Okay, so this is the forwarding DNS server. It's forwarding request onto this computer here, the forwarder. So here I would configure, I don't have an IP address specified, but 192.168.1 dot, whatever the private class IP address is for this caching only DNS server. And this computer would be configured to forward out to the ISP's DNS server. Okay, so what will then happen, like I suggested, any DNS server that we have internally, they'll all be configured to forward through this caching only DNS server. Okay, hopefully that clears up how a caching only DNS server works. Take a look at this. If you have any further questions on this, go through the lab, try and get a better feel of how this works. Refer to the scenario I put together in the lab as well. It's documented a little bit better, might make more sense, and it's using a slightly different example than what we just used. That wraps up our session for Lab 3. We'll see you soon back for the Lab 4 video.